You know, you see them every single day. They're a constant part of our cities. But have you ever stopped to think about the incredible engineering that's actually happening inside a cement truck? Well, today, we're going to pull back the curtain on a silent revolution that's transforming one of the most common and loudest vehicles on our streets.
Just think about that for a second. That constant, grinding, churning noise from the construction site down the road, just gone. And look, this isn't some science fiction fantasy. It's the result of a really brilliant engineering pivot, and it all kicks off with a massive problem. You see, the good old diesel cement truck is basically being squeezed from two sides. It's getting hit with a legislative pincer attack. On one flank, you've got crushing emissions regulations, and on the other, you've got strict new noise restrictions. The old way of doing things, you know, where a giant diesel engine just has to rumble all day long to keep that drum spinning, it's just not going to cut it anymore.
Now, what's really fascinating here is that this pressure is coming from everywhere. In Europe, they've got a system that simulates the truck's entire workday, and it comes down hard on all that time spent idling. Over in the US, they're offering up valuable credits to get companies to reduce that exact same idle time. And in China, the new fuel standards are basically tailor-made to favor hybrids. So no matter where you look, it's a global crackdown that's making that old diesel model incredibly expensive to run.
And then there's the other side of the pincer, the noise. A traditional truck just sitting there mixing concrete can easily top 85 decibels. That's loud. But cities everywhere are adopting new standards, like Europe's PEIK rule, which says that if you want to work at night, your vehicle has to operate below 72 decibels. That one rule right there effectively bans the old-school trucks from taking night shifts, which is a huge blow commercially. So the challenge for engineers was crystal clear. You have to solve for emissions and noise at the same time.
Okay, so the problem is clear, right? It's a huge challenge, but the engineering blueprint that came out of it is, well, it's just incredibly elegant. Let's dig into how they cracked the code.
All right, so here's the technical answer. It's a P2 hybrid system paired with an electric power takeoff, or what everyone calls an ePTO. Now that sounds complicated, I know, but the core idea is actually super simple. It isn't about just jamming in a bigger engine. It's about making the truck smarter by changing one fundamental thing.
And this, right here, is the absolute game changer. The concept is called decoupling. See, in a traditional truck, the same engine that moves the truck forward is also the one that spins that giant drum. With this new system, those two jobs are totally separate. The truck's main engine can be completely shut off, but a smaller, independent electric system keeps the drum spinning. This one idea changes everything about how that truck operates. So, to really get why decoupling is such a big deal, we've got to follow the truck through a typical day's work, or what the engineers call its mission profile.
Okay, this diagram might look a little intense, but it's basically just how engineers map out every single part of a truck's workday. We can actually break it down into 5 really distinct stages.
So first up, you've got loading at the plant. Then, transporting all that heavy, wet concrete out to the site. After that comes the waiting period, then the unloading, and finally, the empty return trip back to the plant. Now looking at that cycle, where do you think the biggest problem lies? Where's all the waste?
And here it is. This is the aha moment. Would you look at that chart? Up to 40% of a truck's entire day, 40% is spent just sitting at the construction site, waiting in a line. And in a traditional truck, what does that mean? It means the engine is idling that entire time, just burning fuel and making noise, all to do one simple job: keep that drum turning.
And this is where the magic happens. On the left, you've got the old way, just wasting 4 to 6 liters of fuel every hour, spewing emissions and actually damaging the engine over time. But on the right, you've got the new way. The engine is completely off. The electric ePTO does the exact same job almost silently, using just a tiny bit of electricity. 0 emissions. And get this, it actually makes the main engine last longer. The difference is just staggering.
Now, arriving at a solution this clean and elegant wasn't an accident. It required making some very specific, very deliberate engineering choices. It wasn't about just grabbing any hybrid system off the shelf. It was about picking the absolute right one for this very specific job.
So, first, to hybrid architecture. Sure, you could go with a more complex P4 system. It exists, but it's expensive, and it's a real headache to integrate into the truck. The P2 architecture, on the other hand, is proven technology. It's cheaper, it slots right into the existing design with minimal changes, and it delivers that core benefit we keep talking about: decoupling. For a commercial vehicle where reliability and cost are king, P2 was a total no-brainer.
Next up, voltage. Yeah, you hear all about 800-volt systems in high-end electric cars, right? Super fast charging and all that. But for a cement truck, a 400-volt system is actually the much smarter play. Why? Well, the supply chain for 400-volt parts is massive and affordable. But more importantly, it's just tougher. It's more robust and reliable in the dusty, wet, and frankly brutal environment of a construction site. This isn't a race car, it's a workhorse. And for a workhorse, reliability trumps everything.
And speaking of reliability, we have to talk about safety. This quote here comes directly from the hazard analysis report for this system, and it is absolutely chilling. The scenario is a maintenance worker inside the drum cleaning it. An accidental startup is, well, it's unthinkable. This risk is rated ASIL D, which is the highest possible level of automotive safety. It basically means the system requires multiple, redundant, military-grade safety protocols to ensure that a catastrophe like that can never, ever happen.
So, when you put all these pieces together, the regulatory pressure, the clever engineering, those deliberate design choices, what you get is a vehicle that has a transformative impact that ripples out way beyond just the construction site.
Economically, you're looking at a 25 to 30% reduction in total fuel use. For a whole fleet of trucks, that is a massive amount of money. From a regulatory point of view, you're future-proofed against the strictest standards. Commercially, it's a game changer. You can now work 24/7 in cities, which is a huge competitive advantage. And for all of us living in those cities, it just means a lot more peace and quiet.
So, the big thing to remember here is that this hybrid cement truck isn't some temporary fix or a transitional step. It is the perfect optimized solution, designed specifically for that sweet spot where tough regulations, real-world work demands, and cost all intersect.
And that leads to one last big question. This same combination of regulatory pressure and smart, targeted electrification is happening all over the place. We've just seen how it can completely revolutionize a cement truck. So the question is, what other boring but absolutely essential machine is about to have its own silent revolution?